Alright guys, so we're going to be doing question 543, the diameter of a binary tree. So in order to do this question, what it's asking you is, given the root of a binary tree, return the length of the diameter, right? And the diameter can be found by adding the height of the left and height of the right. So similar to other questions we've done, such as, like returning the max height, where you have to go through your left height and your right height and return the max. Instead of just returning one of those heights, we're going to be adding them together. And adding them together is what gives you our diameter, right? So for instance, how that's going to look like is in example 1, we are given this binary tree. And to the left, right, we have this equals to 2 because it goes, starting at the root, goes 2 and 4, right? So that's the height. And then for the right side, we have 3. So what we want to do is basically add up the values of the height for 4 and 2, the left side, and the right side, which is 3. So if this is 2 and the right is 1, then the output is 3. And how that would look following it is just 4, 2, 1, 3, right? So let's just draw that out real quick so we have a physical representation. So if we're starting at the root, right, we are adding the left plus the right to get our diameter, right? So left is 2 because starting at root, you go 1, you go 2. So we know the left height is 2, and now we need to get our right height, which is 1 because it just goes down 1, and 2 plus 1 equals 3, right? So walking into this question, we should think of, okay, so now we know how, or at least what needs to be done. We need to get the height of the left, we need to get the height of the right, and we need to add them together and return it, right? That's the first step. Now we know what we need to do. Now, how do we do that, right? So the first thing we're going to do is just do the usual, right? You can create, edge cases or so on, which is if not root, right, return. And then instead of returning none, we're going to return 0. The reason, uh, if root is none, return 0. Okay. The reason why we return 0 is because instead of returning none, we are adding values. And when adding values, even finding for the left and right, we usually return 0 instead of just none because we have to continue going through the binary tree, right? So once we do that, we are going to create a helper function, right? And what this helper function is going to do is help us get the max underscore diameter, and we'll just pass in root, right? And this function is within the function that we're given, and what this is going to do is basically give us the max diameter. This is what all the code is going to be in here for, right? And I'm going to show you why we create a helper function in particular. And this is where the recursion is happening. So this is where the recursion, we're also going to need another if statement. So if root is none, return 0. And then what we're going to do is we are going to create variables left and right. And we are going to have one of them go down the left side of the binary tree, and one of them going down the right side. And you should probably know which ones are which. So in order to do that, we are going to call the same function that we're in right now and set this equal to root.left, and vice versa, when it's left, dot right. Now, what this basically does is, starting at the root, for the first instance, left is going to just run down the whole entire leg, 1, 2, 4, right? Right is going to do the same thing. There's only 3, so it's going to start at 1, it's going to go to 3, and then stop, right? Now, in order to update these values, we are going to need to return, right? With the recursion situation, there's basically kind of 3 steps. You're going to have your left and right variables running through the left of the binary tree and one running to the right of the binary tree. And then in order to update them, you need a return statement, right? This is basically the bread and butter of recursion. Anything else is basically considered edge cases, which is used to stop, right? To stop the recursion at specific points. So we won't get too into detail on that, but what we're doing here is this is now returning the updated values, right? So we get the max of the left side and the max of the right, which is basically getting us the entirety of the left height and the right height. Perfect. And now all we need to do is we need to make an edge case that gets our max underscore height, right? So how would we do that? Well, let's think about it, right? We need to add the values together. We need to add left and right. And we need to see if it's bigger than a certain number, update that value and return it. So we have a rough idea what we need to do. How are we going to do that? So how we're going to do that is first we're going to set a variable outside of the function, so we can have it within here, and we'll call it max underscore height. I know these variable names are not very fitting for the question, but we're too deep into it to fix anything. So we are going to make another variable called current underscore sum. We're going to set that equal to left plus right. We're going to say if this variable is less than current underscore sum, then we're going to set this equal to current underscore sum, right? So what this is doing is you have this max height, which is equal to 0. This is basically our answer, right? This is our answer, and this is what we are returning, right? Let's get some spaces so it looks easier to read. Okay, so this is our answer, and it's set equal to 0 because we're going to be updating this value constantly. Now let's take a look at our if statement slash edge case. So we have current sum. This is equal to left plus right. This is updating constantly, right? So this is updating to make sure that we have the left and the right height, right? So once this is done, left is going to equal to 2, right is going to equal to 1, and the left plus right, 2 plus 1 is 3. That is current sum right now. This is that variable. Now we do an if statement saying if this, self.max.height, which is currently equal to 0, is it less than current sum? Well, once the loop is done, yeah, it's less, right? And even then, there's still instances where it's less than. It's just updating constantly. So the second it's less than, which should be automatically, then you just set this variable equal to the current sum, and you continue going, right? And because of that, current sum changes, self.max height, right, is updated, and once it reaches to a point where it's not great or it's not less than, or we just return 0, there's no more, then we just return the variable we've been updating, which is self.max height, right, our answer. So we're just going to return this here, right, return this, and we are going to call this, right, because we need to actually call the function. We created it, we need to call it, and pass in root, our argument, right? Because this is kind of just a placeholder. We can name this anything, it doesn't matter. But we actually need to pass the actual root, which is this. So with that, I think everything looks good. Let's give it a run. Beautiful. Let's give it a sim and make sure that all the test cases are valid. There you go. Okay, perfect. So the takeaway from this question, to find the diameter of a binary tree, don't overcomplicate it. It is just the left and the right added to one another, the max heights. In order to achieve that, we use recursion, right? recursion is used by creating two variables left and right. This goes all the way to the left. So staying at line 27, right? This line continues running until we're finished. So it goes 1, 2, 4, boom, right? Right, 1, 3, boom, right? There's nothing else. We turn none every time we reach the ends, aka the leaf nodes. And then once we have these values, right, we update them with these return statements, and we continuously check this if current sum it equals left plus right, and if the variable we created, if it's less than the current sum, which is left to right, whatever left is, whatever right is at that moment, added together, then set it equal to that. And once this loop is done, then we return it, right? And this is just here to update the function.